What if you woke up to find the beach outside your window was just gone? That familiar coastline, the stretch of sand you walked just yesterday, seemingly shifted in the dark. It sounds like a surreal dream, maybe even science fiction. But for some coasts around the world, it's a shocking reality. This isn't a story about magic or myth. This is a geological detective story. We're going to uncover the incredible scientific forces that are powerful enough to move, and sometimes completely erase, entire islands in a single night. Before we begin, this is based on real documented events. Hawaii's East Island vanished in 2018. Newmore Island disappeared in 2010 between India and Bangladesh. Lohachara Island sank in India. USA's barrier islands keep shifting. And Iceland's Surtsey Island formed in 1963, then slowly eroded over time. How can a solid landmass, an entire island, just move? It defies common sense. Yet, scientists faced this exact puzzle in October of 2018. East Island, a remote 11-acre spit of sand in the Hawaiian archipelago, vanished. One day it was there, a vital nesting ground for the vast majority of Hawaii's green sea turtles and a nursery for endangered Hawaiian monk seals. And the next, it was simply gone. Satellite images confirmed it. The island was almost entirely underwater, its sand scattered across the surrounding reef. A scientist who had been researching there just months earlier said he expected the island to disappear eventually, but thought it would take decades. Not overnight. So what happened? What kind of force can just wipe an island off the map in a matter of hours? To answer that, we have to look at the powerful and often invisible battle that's constantly being waged between land and sea. To understand how an island can move, you first have to understand what many islands are truly made of. Forget solid bedrock. Think of barrier islands, sandbars, and atolls as something much more fluid. Immense, slow-moving rivers of sand. And the currents that shape these rivers are powerful and relentless. The first major force at play is called sediment transport. Simply put, water moves things. On a coastline, it's constantly carrying sand, silt, and gravel. This movement happens in two key ways. You have the bedload, where larger grains of sand are rolled and bounced along the seafloor, and the suspended load, where finer particles are lifted and carried along within the water itself. This transport is organized by a phenomenon known as longshore drift, the master architect of our coastlines. If you've ever stood on a beach and watched the waves, you've probably noticed they rarely come straight in. Driven by the wind, waves usually hit the shore at an angle. This is the swash, and it carries sand up the beach at that same angle. But when the water recedes, the backwash, gravity pulls it straight back down, perpendicular to the shore. This zigzag motion, happening with every single wave, creates a current that runs parallel to the beach, the longshore current. Think of it as a massive natural conveyor belt. It picks up sand from one part of the coast and drops it off somewhere else. This is why you'll see sand pile up on one side of a jetty while the other side is stripped bare. The structure has interrupted the conveyor belt. For an island made of sand, this process is fundamental to its existence. Longshore drift is constantly eroding one end of the island and depositing that same sand at the other end. Over time, this literally shifts the island's position. It's a slow, methodical migration. Along Virginia's eastern shore, for instance, some barrier islands are migrating toward the mainland at a rate of nearly 20 feet per year. It's not moving overnight, but it is perpetually in motion, a river of sand flowing through the ocean. This constant, gradual movement sets the stage for something far more dramatic. The slow, steady work of longshore drift can sculpt a coastline over decades. But a single storm can unleash that same amount of change in a matter of hours. Hurricanes and major winter storms are the game changers. The brute force that can take a slowly migrating island and shove it across the map or wipe it out entirely. Here's how. A major storm doesn't just bring wind. It brings a staggering amount of energy, which is transferred to the ocean in the form of storm surge and massive waves. Storm surge is a bulge of water pushed ahead of the storm by its powerful winds. It's not like a normal tide. It's a rapid, catastrophic rise in sea level that can be several meters high. When this wall of water hits the coast, it doesn't just flood the land. It acts like a bulldozer. The waves riding on top of this surge are a second, devastating force. While gentle waves might push sand onto a beach, storm waves claw at the shore, pulling immense quantities of sand with them. This is called overwash. During an overwash event, the surge and waves are so high they flow completely over a low-lying barrier island, carrying sand from the beach and dunes and depositing it in the lagoon behind the island. This is precisely how an island moves overnight. It's not that the landmass relocates. Instead, the storm violently erodes the ocean-facing side and deposits that material on the landward side, effectively shifting the island's footprint. The island hasn't teleported. It has rolled over on itself. And that brings us back to East Island. Hurricane Walaka, a Category 5 storm at its peak, passed close by. It wasn't even a direct hit, but its storm surge was enough to completely overwash the low-lying island. The waves and surge acted like a giant eraser, scouring the sand from the reef and washing it away. The overnight disappearance was the terrifying climax of natural coastal processes supercharged by the immense power of a single storm. This phenomenon isn't just confined to remote atolls. All around the world, communities are built on these dynamic, moving landscapes. The Outer Banks of North Carolina are a classic example. These are quintessential barrier islands, and they are constantly in motion. Storms frequently cut new inlets, separating one part of an island from another, while longshore drift works to close up old ones. Roads get buried, houses are undermined, and the very shape of the coastline is in a state of perpetual flux, with some areas losing 25 feet of shoreline or more in a single year. For the people living there, it's an endless battle. They build and rebuild dunes, nourish beaches with dredged sand, and even move entire historic lighthouses inland to save them from the encroaching sea. It's a testament to both human resilience and the sheer, indomitable power of the coast. It's not just erosion either. In some river deltas like the Mississippi or the Sundarbans, rivers deposit vast amounts of sediment, creating new land. But even this is a double-edged sword, as the same coastal forces are constantly working to reshape that new land. Sometimes, our attempts to control these forces backfire spectacularly. When engineers built jetties to stabilize an inlet on Tucker's Island in New Jersey in the early 20th century, they thought they were solving a problem. But the structure starved the island of its sand supply from longshore drift. The island began to erode at a catastrophic rate, and by the 1930s, storms had washed away the last of it, destroying the lighthouse and erasing the island from the map. It was a harsh lesson. When you try to dam a river of sand, it often just carves a new, more destructive path. So an island doesn't just pick up and float away in the night. Its movement is the result of a powerful partnership between two forces. First, there's the slow, relentless work of longshore drift, the constant conveyor belt moving sand along the coast and causing islands to gradually migrate. And second, there's the catastrophic power of storms, which can compress decades of that gradual change into a single, violent event. The overnight shift is a tipping point, a moment when a system already in motion is hit with a force so great that it is dramatically and irrevocably altered. This has always been the nature of our planet's coastlines. They aren't static lines on a map. They're dynamic, living boundaries. But today, this process is being accelerated. Rising sea levels, driven by a warming climate, act as a threat multiplier. Higher seas mean storm surges can reach further inland and be more destructive. Warmer oceans fuel stronger, more intense hurricanes, increasing the frequency of these dramatic reshaping events. The story of the moving island is a powerful reminder that we live on a planet that is constantly changing right under our feet. The shores we see today are just a snapshot in a long, ongoing geological drama. And as the climate continues to change, the pace of that drama is only set to quicken, forcing all of us to confront the reality of living on shifting ground. If you enjoyed this exploration into the powerful forces that shape our world, consider subscribing and hitting that notification bell. We're always digging into the science that explains our planet, from the deep ocean to the highest mountains. And let us know in the comments below if you've ever witnessed the dramatic power of the coast firsthand. Thanks for watching.